Okay, here we are again. It's 7 o'clock with Ali Lloyd. And let me just, as always, confirm that we do in fact have some people here. I see we have 43 people already. And hopefully if somebody could confirm that they can in fact see and hear us again, that would be grand. Just there we go. Yes, we are. Brian got there first this time, not Matthias. Matthias is lagging. And Clarence and Tom and Jerry. Tom and Jerry are here. And that's all very good. Okay, grand. All right then, Ali, you're up. What widgets are you going to wow us with this time? Let's hear it.
I'll tell you. Hi everyone. Hope you're all doing well. This is the third part in the seemingly endless building widgets session. I don't know what to call it. Session. Yeah. Anyway, let's get on with this. I'll just start my slides here. Let's see. Right. So this month, I've got 4 things to sort of tell you about. The first one is pretty simple, just a toggle highlights property that I've added to the segmented control. Then we're going to talk about loading custom Java resources again. Pick that up from last time. Then I'm going to tell you about adding tab navigation to the palette actions widget. And then finally, I'm going to talk about Objective-C infinite LiveCode with some examples, and a bit of a comparison between native widgets on Mac and on Android, as are the 2 examples we have so far. Okay, so this is launching straight into the segmented control modification. Just an aside, if you want to tweak one of the extensions that's packaged with the IDE, I usually just add a suffix like .develop to it. That just means that when you load it in the IDE, it doesn't conflict with any existing extension names. So there's a couple of slightly interesting things about adding a toggle highlights property. So one thing is that it overrides an engine property. Well, I say overrides, it's the same name as an engine property for list fields. And the other thing about it is that it doesn't need any handlers. So it's a very minimal example. So I thought it might be useful just to stick a list of the reserved property names. I just grabbed these from the engine. There's a big switch statement that tells you which ones are reserved. So these are reserved because they're general control properties, plus kind, which is widget specific. So things would go pretty badly wrong if these were allowed to be overridden. These properties appearance in the PI, though, they can be changed. For example, segmented control ensures that for color and its PI label are appropriate for the segmented control. So all you do for overriding the property inspector appearance of a built-in property is just add metadata for it, but no actual property declaration. So here's what we've done for the segmented control, just to change the label to segment label color. So despite the fact that it's a reserved token, it's fine to use for a property name. this toggle highlights, and it makes sense because it's basically the same property as toggle highlights for list fields. So this is the entire property declaration, getter and setter implementation and docs for that property. So you can see that the getter and setter, it's just linked to the value of a member variable. We don't need to actually call any handlers or anything when that's changed. And there's some standard other stuff, so it's a Boolean property, defaults to true. We want it in the basic section, and clicking toggles highlight to try and come up with the snappiest label for what that property does. Okay, so yeah, I've just said this. The property doesn't need to trigger a redraw, so it can just be associated with the mToggle highlights variable. And the value of that variable is only relevant in one place, which is the code that responds to a mouse click. So all that needs to be done is checking, whenever it checks if the segment is already selected, just check if mToggle highlights is also true. And if so, then we can deselect that segment. There's a little bit of extra stuff here because we've got two cases for if you're allowed to select multiple segments anyway. So again, here we've basically got the same logic. And there's a full diff there. So just a really simple example of adding a property, and it solves a bug to do with a text-align widget. I just thought there were some nice aspects to it, so I pop it in here. Now, I don't know, I should probably stop there and see if there are any quick questions. I'm sure if there will be. Oops. It's a good way of.
You need to turn your camera on again. Oh, there we
Sorry. Hello. Okay. Yes. Any quick questions about that? Doesn't look like it, so maybe I'll just crack on.
Very good.
Okay. Exit that screen next time. Okay. So on to picking this up from last time, loading custom Java resources. Last time I showed how the LC compile FFI Java tool could be used to wrap a Java library that Herman had posted a question about. In DP9, we'll add limited support for loading jar files. It's limited because code resources and standalones is kind of a tricky issue that we need to get right. And there are any number of ways to hack stuff in, but really want to make it robust and as future-proof as possible. So I'm treading quite carefully in that regard and make sure we spec everything out and get it right. But I have added some stuff to make it possible to load jar files. So it'll be necessary to set the class path environment variable before any Java FFI is used. This is because the way I've added it, it's just when the Java virtual machine is initialized, it will use the class path environment variable to to load up any jar files that are in that variable. So for the purposes of developing and testing a widget, this is good enough for now. So here's going back to Herman's filter example. We'll use the JHLabs filters Java library to grayscale an image of my cat onto. People call him a grey cat, but as you can see, having grayscaled him, you can really see the blueness in the original image. So in addition to the generated wrapper code, which I'll show you again if you want in the LCB file, it's also included in the resources folder next to these slides. All we need is just the API calling from LiveCode script. So this is just using the API in the sort of dumbest way possible. You pass in the RGB value and it will return the grayscaled RGB value. And then, so in order to load the library, we can load it with the test button, but we just need to ensure the class path variable has been set. So I've included the filters.jar file as well in the, you can just download that from the JHLabs website. And yeah, as long as you've set that class path variable, then loading or testing the library will work. Due to the nature of that API, we need to do a bit of manipulation of byte sequences into hex values and stuff before passing them. This code is meant to be more perspicuous than fast. So this is a kind of standard thing, I guess, if you're working with image data. It's splitting each block of 4 up into the alpha RGB bytes. So here I'm just constructing a number, and I sort of found the most, feels like the clearest way is just to create a hex value and setting the upper 2 and then the middle 2 and the lower 2 digits. So I'd like to know if someone knows if there's a good word for, because obviously digit just means in base 10 as bit would for base 2. So what's the word for a hex one? If anyone knows, let me know. And then here's the actual thing that takes that number, gives it to the LCB library to grayscale, and then unparses the bytes and builds up the grayscale image. So I haven't tested, but I suspect the speed of this could be improved by moving much of the code. I mean, this is calling the LCB library once for every 4 bytes of the image. So it's definitely not going to be the most efficient way to use the API. But the point is more just to demonstrate that it can be used. So yeah, you could tweak things so that it passes the image data to the LCB library, which would then do all of the bit shifting and masking operations to build the RGB value and extract components and rebuild the grayscale image data. So I thought I'd do a quick demo of this. So here's the stack. I've just copied the image so that it's the same size, because otherwise you run into trouble with the image data. It has to be put into an image of the same size. And let's load this library. but not before. See, I've done this before. Putting the jar file into the class path variable, and I think it's always worth just checking, make sure I've got the path right. In fact, yes, but there is a file. Okay, so now I click test there. That's the library loaded, and now we should be able to grayscale this image. Oh, that's going to take a long time. So my laptop is evidently using a lot of resources to power the webinar software. So, oh, never do live demos. Well, I can assure you that's worked several times before I was running the webinar. So let's pretend that that worked. Okay. I think that's the end of that section. So, does anyone have?
There we go. I think we do have a couple of questions this time, Ali. So let's have a look. Also, you have an answer. Well, you have an answer to your question.
Hexit. Yeah, Hexit. Oh, there's actually a link. Okay, that's good. Does sound a little bit like Brexit, which is. Okay. No worries. Well, let's gloss over the crash there and plow on with the presentation. Okay. So the next item here is the palette actions tab navigation. So I plan to add tab navigation with the following properties. The widget should always display at least one tab. Will show relevant navigation arrows if and only if there is content to reveal. And when clicked, the arrows reveal as much previously unrevealed content as possible. So this is what it's for. There have been a few complaints that the property inspector likes to dictate its size, and that's essentially because we didn't have this feature. So I thought it would be quite a nice thing to knock up, both from the point of view of this talk, as it illustrates some thorny issues related to layouts, and also the side benefit of fixing this irritation with the property inspector. So the main issue is just to refactor the tab rect calculation. So the way the palette actions widget works is just every time it needs recalculation, it just marks the mRecalculate variable to true, and then if onPaint is called with that variable true, then it will recalculate the recs of everything. So that's quite a common pattern, at least in the widgets that are bundled in the IDE. So I needed to refactor so that there were 4 different handlers that were kind of useful. So one that just calculates the recs of all the currently displayable items, one that finds the last displayable tab index, one that gets the width of an icon, and one that gets the rect of a displayable item and updates some variables so it can be called on the next displayable item. So using those refactored handlers, I think some of the details here are not that interesting, but hopefully some of the lessons kind of are. So being able to calculate the last displayable tab means that we can just try the layout with different first tab indices and find the value that reveals the newly displayable tabs, as many as possible. And if we're going back, then we want to find the one before the first currently displayed tab, and make sure that's displayed, but also display as many new ones as possible. And similarly, going forwards, you want as many new ones as possible, including the one after the last one currently being displayed. I hope that sort of makes sense. And the result of clicking a navigation icon is that the new first tab to display is calculated. So it iterates through trying out different first tabs and seeing if the conditions are met. So the general calculate tab rect handler just becomes, if there's no data, return empty, find the recs that would be needed to display all of the tabs from the given first tab, and then working backwards, just don't display any tabs that, if there was a forwards nav icon, it would overflow the action icons. An aside on tooltips, at the moment, I don't know if anyone's experimented with tooltips with widgets, but basically you have to just set the entire tooltip of the object based on where the mouse is positioned. So just an aside there, that's another thing that I had to add just to support this feature. So the key points, while I was doing this, I was sort of thinking, what lessons could I learn? Because I think there are a few. This is one of the first widgets I wrote, I think, and I would have written it quite differently if I was writing it now. But there's really key things which are separate measuring handlers from drawing handlers. Don't commit values back to member variables inside the measurement handler. So what I mean by that is make sure you've got functions that return, say, all the rects, and take the return value of that function, and if you're storing them, put it in the member variable, rather than working with the member variables. I guess it's just generally correct abstraction of your handlers. Get things right before optimizing, because you might find that repeatedly measuring something until it fits is fast enough, probably not even noticeable. I think I have in the back of my mind that measuring text is slow. I guess it's probably not fast, but I mean, from the point of view of end users, it's pretty fast, unless you have to measure a lot of text. So try it, and then if something needs optimizing, then you can optimize it later. And the final thing is that multiple dependencies in layout is quite hard unless you've planned exactly what information needs to be available at each stage. So we also have this issue with the graph widget. and for a long time it didn't have the ability to label axes. And it's a slightly trickier thing than you might imagine. I've sort of broken down the steps here. The first step is to find the largest label of the y-axis. That determines the left straight edge of the graph. And then you have to figure out if the x-axis labels that you want fit when the leftmost one is aligned centrally with the left edge of the graph, as it is in this picture. All right, well, what if it doesn't? Then, if it doesn't, then they need to squash up, and then they take up more vertical space. But that then means that the bottom edge of the graph is in a different place depending on whether these have to squash up or not, which then determines how you can lay out the x-axis labels. So it's almost circular. You have to start with the largest x-axis label and figure out the entire rest of the graph layout from there. So these things are much easier to code once you've figured them out first, is basically the lesson that I've learned from both of these examples. Again, there's a pull request for this, so if you want to take a look at the diff at this GitHub link. Okay, quick check there. I didn't see any questions, so I'll just go on with the main event, I suppose. This is the Mac native field. So I've got a little video here. I was wise enough to do a video just in case the demo didn't work, but I'm sure the demo will work. Now, there's not too much to prove that is a native field, but you can see actually it goes really quickly there. On Sierra, there's a nice sort of focusing of the focus border effect, which you get free should you want it. So that's it was pretty easy to do, especially from the there you go. Having the Mac native button example as well, it's very similar. It's not a full strength native field widget. It wraps the NS text field, which is intended as a single line field. And it only has a single action applicable, which is triggered by the return key, rather than sort of more sophisticated messages like text changed. And for those, we need to wrap the NS text view. Most of the work has been done to support wrapping the text view with its associated actions, but it's not quite finished yet. It will be done very soon. It should be in DP9. So the initial version of the Objective-C FFI is done and is available already in DP8. I'm just going to point out some of the differences or similarities between the foreign handler declarations and binding strings, because to be honest, the rest of the stuff, the sort of considerations and things like that, are largely the same between writing a native widget for Android and Mac, and even iOS. Once we've finished off the iOS part. So I've just put up a couple of examples here of the setting and getting the text of the field. This is getting the text of the Mac native field and getting and setting the text of the Android native field. So the first thing to note is that Objective-C foreign handlers are unsafe. If you get the lifetime semantics wrong, LiveCode will probably crash. It's mostly not going to be something you have to think about, and in the future we should be able to automatically wrap these in such a way that you don't have to think about it at all. Indeed, I think Mark may have said last time that he had 95% of the OSX SDK wrapped or something like that. So it's not going to be something you have to worry about in the future. At the moment, it is to some extent. And this is probably the only way you'll have to think about it for simple examples. If the underlying object is expected to have its reference count incremented, then it needs to have the type Objective-C retained ID in the foreign handler declaration. Largely, this will be, if it's just simple objects like the text field that are being wrapped, it will only be the alloc method that returns a retained ID. And it's just, obviously, LiveCode needs to know what the lifetime of that object is, and whether it needs to do any kind of cleanup, or whether it can expect the object to be around. So static Objective-C methods, that's ones that don't require an instance of an object, are bound using a plus sign for the method name. And this is just standard for how they're annotated in Objective-C. Whereas in the Java ones, if you're used to them already, they have an exclamation mark and the word static at the end. So these essentially mean the same thing. Whereas instance methods in Objective-C, there's a minus sign there, which is, again, how they're annotated in Objective-C. It's the default in Java binding strings, so you don't actually have to write anything extra to specify an instance method in a Java binding string. Although you can actually add exclamation mark instance at the end if it helps for your own sort of annotation. In both cases, the instance that you're calling the method on is the first parameter in the foreign handler declaration. So that will always be an Objective-C ID or retained ID and or a J object in the Java case. Objective-C methods have pseudo-named parameters. It's just, again, how the syntax works in Objective-C. So it's pretty similar in these binding strings. You just each parameter name in the binding string has a colon after it. And in Java binding strings, there's no sort of explicit naming of the parameters or anything. It's a list of type codes that are in the parentheses that give you the types of the parameters. So once the Objective-C foreign bindings are sorted out, there is very little difference between the Mac native objects and the Android ones. It really just depends what properties are available. I've sort of crowbarred some examples in here of basically what it could look like for a Mac native object and an Android native object, and put the code next to each other here so you can see pretty much how similar they are. There's some slight variation. For example, Android widgets tend to need the engine context as a parameter to the constructor, whereas you don't need that for Mac. Getting the pointer, the raw pointer from the wrapped object is the same. I need to say I should have changed this to M text field view here. That's a typo. And then so obviously I've just named these two things the same, but you'll see in a second that adding listeners or sort of action listeners or callbacks is pretty much very similar in the two cases. So here is the two examples of the return key message and how that listener gets added in both cases. So it's slightly different in Objective-C. You need to create a proxy which then becomes the target of the actions on the actual view, and then you set a callback for its action. Now this is in the slightly I want to say sort of degenerate case. I guess it's where the control itself is highly specific and only has one action associated with it. You can find out from the API, the Apple docs, what action it's meant to represent. In this case, with a single line text field, it's just the return key message. So we just need to associate a callback with the appropriate parameters to the action on that particular object, and post return key to LiveCode script whenever that action is triggered. And this is exactly the same conceptually for Android for the same message. We create a listener, which is a bit like the proxy over here, and set it on the text field. And the callback, it's basically the same. It's slightly complicated here by the fact that we need to break the wait loop on Android to wake up the engine. I think I talked a bit about that last time. And here is I've snuck in a new thing here to the Android widget, which is that the listeners can actually return a value. So in this case, it lets you return false if you want to allow the return to create a new line in the field, or return true if you want it to be eaten by the field. So that's a small extra difference there, but it's not significant for this example. And then another thing that you need to think about with these widgets is if any of their properties can be changed through user input. Now, obviously, a field widget is a good example of this, as the text can be changed from typing. So we need to keep the variable updated when the view is destroyed, so that we can put the correct text back in the fields when it's recreated, which happens on leaving and returning to the card. Just beware if you're writing any of these in the back of your mind, whether it's an aspect of the control that can be changed by the user in some other way than through script. So here's a side-by-side comparison again of the code that does that. As you can see, it's pretty much identical. Here we've got a string from JString, and here we've got a string from NSString. And the one slight difference is that on Mac we store the proxy, whereas we don't need to do that on Android. Okay, that's basically the end of my presentation. I finished a little bit early. I don't know if I'll have a look and see if anyone's got any questions for me right now. Again, if you have any. Oh, sorry.
We do have a couple of questions this time.
Okay. But yeah, I'll just reiterate that if you have any sort of things you want me to talk about, please email support@livecode.com with the subject and widget queries, and I'll hopefully be able to answer them to your satisfaction. Okay. No. Turn screen. Hello. Oh. I did press that. Great. Okay. Roger asks, what are the benefits of a Mac native field over a LiveCode field? Well, the benefits of all of these native fields is going to be things like I showed you in the video, you get the focus border animation. You'll get scrolling effects, all of that stuff for free, because that's all built into the control on the native level. With LiveCode fields, we're always going to be chasing the tails of all these operating systems a bit when they come up with new versions and effects that they have on there. If we tried to emulate them every time, it would be completely unsustainable. So the end goal here is to get, I think it was mentioned earlier, a generic field object, widget, which on each sub-platform, or not sub-platform, each platform appears as a native object on that platform. And then we're effectively getting true native appearance and behavior, whatever operating system it's being used on. So it's really it will be a very efficient way of keeping things looking correct. Oh, so Dan has asked that question. So yes, that's what we're working towards. I think what we'll probably want to do is have, as I say, the generic widget that behaves as much like a LiveCode field as possible, but is has native appearance and behavior on all the platforms. But also, there will be some properties that native widgets can have that are not applicable across all platforms. And so if you know that you're just developing an Android app, for example, you'll be able to use the Android specific version of that widget, which means you'll get all of the features that the native widget gives you. So hopefully that's the best of both worlds. Roger says, so it will gradually replace the emulated fields. Yes, it will. I would have thought it would do that pretty quickly. If you think about all of the fudges that you probably have to do if you're a multi-platform developer to get things looking consistent, then yeah, it's going to be much easier when you've just got the single object that appears, right? Jim L says, are transitions or animations amenable to widgetization? In a sense, yes. I mean, if some of these transitions and animations are built in to the native controls, so they'll effectively will get them for free for certain types of controls that we wrap. I think you actually, even before that happens, it would be quite a good thing to try to. So I don't know if not much has been done with the child widget pattern. But I think that would be, sorry, I've just realized I'm cutting off the top of my own head. It's not Heather's fault. I think at the moment you could do something with child widgets that it would be much easier to do than in, well, maybe not easier to do in LiveCode Script, but it would be easy to do in LiveCode Builder. So that would be worth trying, I think. But yeah, as I say, some of the native stuff you'll get for free. Are we working on any other native widgets beyond the text field? Yeah, kind of. We're just working on anything we can in in any spare time we have. Like when a new platform appears, so the iOS tweaks for FFI will appear shortly. I imagine there'll be a sort of frantic rush to do as many native widgets for that as possible. There are various other things in the works, but I don't know that I would like to commit to saying that we are doing any other native widgets. We will be doing more, but specific ones I've certainly tried a couple of times thinking that I could do something, and there's been a couple of roadblocks there. So obviously it's a good way of finding out what features we need. So yeah, maybe I'll be able to tell you about some other ones. I'll definitely be able to tell you about some other ones next time. But the text field is our main focus just because it's one of our commitments for the Infinite LiveCode funding. Herman asked if the field widget is already usable as a child widget. Yeah, any widget is. No, actually, that's a very good point. So native layers, there's a slight issue in that native layers can't be interleaved with non-native layers at the moment. So I'm not sure. You could try using it as a child widget. I wonder if okay, so certainly it could be used as a child. You could do things right now where native layout sort of control things could have another native layer as a child. But yeah, you wouldn't be able to actually do very much with the native widgets as children in sort of the general LCB at the moment. That's a good point, Herman. I didn't think about that. Greg says, do the native fields change much? i.e., if we build an app for one version of iOS, how compatible will it be with other versions? Well, the great thing about that is that it will literally adapt to whatever version it's in, because it is just using the native API. So they change as much as they are changed by Apple, for example, on each iteration of iOS. So in the near future, Michael says, so in the near future, there'll be no need to implement a native scroller on mobile. It will be there out of the box. In a sense, for native controls that have native scrollers, like fields, there wouldn't be a need. You would still want them though for, say, you might want a group of LiveCode objects, or you might want a group of non-native widgets, which you want a scroller for. But the scroller at this point will be itself a native widget. So you will be able to do things like use native scrollers to scroll your groups of other stuff, and it will have all of the nice bouncy things that the OS gives you.
Okay. I think we are now out of time, Ali. So unless anyone wants to quickly pop in any more questions really fast, we're going to wrap this one up. No, not seeing anything. So okay. Thank you for that, Ali.
Questions, good questions there.
And do send Ali your suggestions for things that he can do next month. I know he's always interested to hear what you want. And we are now going to have Mr. Greg Pink Miller up next. So rejoin me again in a couple of minutes. I will hang this one up and open the next one.